Hello everyone, I hope you all are well and making progress in life. Here is Priyanshu and welcome to the Infinity Mind. So today I will be solving the problem count subarrays with given XOR. So the problem statement says that given an array of integers array and a number k, count the number of subarrays having XOR of their elements as k. So in the example we can see that we are just given an array and we are given k and we have to find the number of subarrays that have the XOR equal to k. If we XOR all the elements inside that subarray, it should be equal to k. And so we have to find the count of that subarrays. So from the example one, we can say that the subarrays having XOR of their elements are, in the explanation it is given that 4, 2, these two, because 4 XOR 2 is 6, and next 4 XOR 2 XOR 2 XOR 6 XOR 4 is also coming 6. So similarly there are total 4. Alright, so we have to find that count of that subarrays. So what is the brute force approach we can think of? We can generate all the subarrays. Alright, we can generate all the subarrays and just have XOR of them and just check if if the XOR is equal to k or not. And if the XOR is equal to k, we will say yes, we have got a subarray and we will increase the count. But creating all the possible subarrays, this will take at most time complexity of big O of n square, starting from I is equals to 0 to end, and again j is equals to 0 to end, and for every I to j we can just check that yes, this is our subarray, and we all know what is a subarray: contiguous elements in an array. So this will take big O of n square time complexity, but according to constraints we have to just optimize it. We cannot afford big O of n square time complexity, we have to reduce it. So what we can do, next approach which comes into my mind is using an ordered map, the similar way we used to solve previous question of the SDE sheet. So similarly we will solve this question using an unordered map. So for example, I take this example 42264. So 42264. What I will do, I will just create a map, an ordered map, or we can use whatever we want frequency, an ordered set. So I'm using this unordered map, and suppose I am here. So first I will tell you the logic. What I am saying, that suppose we are at an place where XORing all the elements, this will XOR of all the elements till we have reached is suppose x. Alright, now if we find in the starting x XOR k, so can we say that we will get a subarray here whose XOR will be k? Why? Because see, we are at any element and XOR of all that element still here is x, and we want a subarray whose XOR is equal to k. So can we just check in the unordered map that if there exists any element whose XOR is x XOR k, then we will definitely get a subarray with XOR k, because we know that this x k XOR k will be equal to x. If till here we have XOR x and we want a subarray k, any subarray k, starting ending here we want the XOR k. So what will be, what prefix XOR, we can say we want it from the starting. This should be definitely XOR k. Alright, like in the question in the sum, we used to do that we if we find any in the map sum minus k, we will say that here we have got a subarray with sum equals to k. So similarly here also, this will, if we find any subarray in the starting, from the starting, so whose XOR is XOR k, we will say that yes, we have now find a subarray whose XOR is equal to k. So here also we can see this is giving us x only, because k XOR k will be 0 and x XOR will be equal to x. And if I tell you how I get to know that this will be XOR k only, so we can see from the starting to the end, all the elements XOR is k. And let's say we want a subarray ending here whose XOR is k, and here from the starting if we find any element y whose from whom which we XOR with k, this will give x. So we have to find y, and using XOR property, if we XOR, we have to find y using XOR property. If we XOR k both the sides, so we will get y XOR k is equals to x XOR k. So k XOR k will be 0, so y is equals to x XOR k. That's why I was saying that if we find any x XOR k in the starting, we will get a subarray ending here where whose XOR will be equal to k. So for checking if there any XOR key exists or not, we will just use an ordered map. We will store here and we will just count. Okay. Alright. Now from the example we can say that we are here. The element is 4. And what is k? K is 6. K is 6. So we want any subarray. We are here and we have got XOR equal to 4, and we want a subarray whose XOR is equals to 6. So from starting, from if the in the ordered map, if it contains 6 XOR 4, then we will say that yes, we can get a subarray who will XOR, who will give us the XOR k. So we will just do we will just find 6 XOR 4 in the unordered map. What is 6 XOR 4? I don't know, and I will use XOR of A and B calculator. I will use for explanation. So I want a calculator. So let's use any calculator online. So 6 XOR 4. So I want decimal. 6 XOR 4 will be 2. So is there any 2 in the map? No. So okay, no problem. We will just move. Before moving, we will store also that we will store that till here we have got a XOR 4. This will store prefix XORs. Alright, so here currently our XOR is 4. So we will store 4 and count of 4 will be 1. Now wait, what happened? Some internet connectivity issue. Let's wait for a while. Just I think it has, the page has been reloaded. Some issue is there. There is a problem here. I think it will reload soon. Yes, it's now reloaded. Now we are here. Now till we have stored XOR 4. So here we will store 4 and count of 4 this will be 1. Now we are here, we got 4 XOR 2. Now 4 XOR 2 will be 2. 4 XOR 2 will be 6. Now the XOR has become 6. So we will just go and find if 6 XOR 6 exists in the map. So what is 6 XOR 6? 6 XOR 6 is 0 because same element XOR is 0. So we'll just go and find if 6 XOR 6 exists in the map. So it says it does not exist. But can we say that if we take this whole subarray from starting, we will get 4 XOR 2 is equals to 6 and this will be equal to 6. So that's why for being safe from this edge case, we can say that yes, we have 0 and we will just keep it count 1. So whenever it will say that the XOR is equals to k and we have to go just found 0 in the map, we will say yes, we have found, because we will take the whole array from the starting. Now next point, moving ahead, and yes, count will also be increased now, okay, because we have found. So count will be increased by map of the XOR we want. So count of 0 is 1, so now it will be increased by 1. And yes, we will also store that 6 XOR 1 we have got. Till here we have got 6, and we will also store prefix XORs. Now we have moved here, so our XOR has now become 6 XOR 2. 6 XOR 2 is 4. So we will just go and find 6 XOR 4 in the map. So 6 XOR 4 will be 2, and we will just go and find 2. Is there any 2 in the map? No. So we will say that there is no 2. Until here, what prefix XOR we have found? 4 was found. So we will just go and increase the count of 4. So this will be increased. Now here, now till here the XOR prefix XOR will be 4 XOR 6. 4 XOR 6 is 2. Now if we have to find this XOR k, this will be 6 XOR 2. If 6 XOR 2 exists in the map, if 4 exists in the map, yes, 4 exists in the map, and 2, there exist 2 subarrays. We can find 2 subarrays. We can choose 2 subarrays whose XOR will be 2, whose XOR will be 4. So we will increase our count by 2. So this will be now 3. And we will also, what was the XOR? 2. So prefix XOR was 2, and we will just increase the count. Now moving here, so now the prefix XOR is became 2 XOR 4, that is 6. So we will just go and find 6 XOR 6. 6 XOR 6 is what? 0. We'll just go and find 0. Is there a 0 exist in the map? Yes, 0 exists. So we will increase the count by map of 0, that is 1. So this will be now 1. Now we will store the prefix also, that till now 6 has, we have seen 6 also. We will increase the count of 6. So now moving ahead, the array is completed, and we will just return the count. So count is 4. Let's verify the answer, and yes, the output is 4. So we can see that using the same logic which we used to find the subarray sum equals to k, similarly we are just doing the same using the same logic, subarray XOR equals to k, same logic. Just there we were finding sum minus k in the prefix sum map, and here we are just finding x XOR k in the prefix XOR map, nothing else. And we are just increasing the count. So if I just implement this, First of all, I will declare the size of the array, that is int n is equals to ar dot size, and then I was using an ordered map. We can use anything, map anything, and this will be map. And for storing the count, initial count is 0, and now iterating to the map, iterating to the array, I should be less than n plus plus I. So what I said, we will just XOR also every element. Initial XOR, let's say it's 0, and now we have to return answer in long. I will return the answer in long. So let's say we have to count. So let's say count is in long data type. Now what I said, first of all, I will XOR every element. So this will be array of I. Next, what I said, I will go in the map and find if there any XOR k exist. So if it doesn't exist, it will return 0. So let's say I will go and find if XOR key exists in the map or not. I can use map.find also, and what after finding, we will just increase our count by the map of that XOR k. So can I directly write count plus is equals to map of XOR k? Because suppose if XOR k doesn't exist, it will just simply return 0. So count will be increased by 0, and if it exists, then it will increase the count by map of XOR k. Alright, now what I said, after just doing this, what we have to do, we have to just store in the map also our current XOR which we are getting. So map of current XOR, that is XO, the count will be increased. Now what we have to do, in the starting I said we will just store 0 also. So in the starting, map of 0 will be 1, so that we can take the whole array from the starting. Now I can just simply return count, and we are just iterating to the whole array. We are just XORing every element in the array, and the prefix XOR which we are getting, we are storing also, and before storing we are counting also. If we find any XOR k, it means we will get the k, so we will increase that count with map of XOR k. So if I submit this, so let's check we are able to pass all the test cases or not. So yes, we are able to pass all the test cases, and we have solved this problem successfully. So if I talk about the time and space complexity, so time complexity is we are just running a for loop from 0 to n, 0 to n minus 1. So time complexity will be big O of n, and space complexity, we all know we are using map, and at max we are inserting all the elements. So this will be O of n, but listen, we are using an ordered map. In the worst case, in the very worst rare case, extreme rare case, if collisions occur, inserting into map will take around big O of n time complexity. So this can go big O of n square, but yes, we are not assuming that there are any collisions. So this will, we are assuming inserting time complexity in map is big O of 1. But for making very safe, we can also use map, which storing elements will take log n time complexity also. But yes, we can say that here we are, if not assuming that extreme rare and very rare case, skipping that case, so we can say that yes, our time complexity is big O of n. Alright, so this was all about this problem. I hope you understood. Thanks for watching. Till then, keep learning and keep upgrading yourself. See you in the next video.